finding the maximum and minimum values of given quadratic equation. So before finding the maximum and minimum values, we have to know the graph of a curve which is in the form of y equals to ax square. Okay, we have to know the graph of a curve y is equals to ax square. So if I am considering a is equals to 1, that means a greater than 0. What is the shape of this curve? Y is equals to ax square. So now I am tabulating over here the x values and y values. Okay, if we tabulate the x and y values, then if x is equals to 0, okay, if x is equals to 0, what we'll get? Y is also 0 square. Okay, a is 1. So if a is 1, this curve will become y is equals to x square. If a greater than 0, it is a positive, y is equals to x square, and if x is equals to 0, we obtain y is equals to 0. If x is equals to 1, the value of y is 1, and if x is equals to minus 1, then what is y? Minus 1 whole square, again it is plus 1, and if x is equals to 2, we will get it as a 4, and x is equals to minus 2, and again we will get it as a plus 4 only. If x is equals to 3, we will get it as 9, and for minus 3 it is 9 itself. So whatever the values of x, either positive or negative, we are getting the y is only the positive values. Now we will try to plot this curve on x and y axis. So what it is, which is an horizontal x, and we are considering it is as y. So whereas this is the origin 0 0. Okay, so what is happening over here? If x is equals to 0, y is equals to also 0, which is the point, and if x is equals to 1, we are getting y is equals to 1. Okay, x is equals to 1, we are getting y is equals to 1, and if x is equals to minus 1, again we are getting y value as plus 1 only. Okay, we are getting y value as plus 1 only, and if x is equals to 2, okay, the value is plus 4. Okay, if x is equals to minus 2, the value is also plus 4. Now over here it is 1, it is 4, and for 3 it is 9. Okay, if we 9, let's consider which is, if we draw all these lines, okay, if we draw all these lines, then we will get which is the shape of the y is equals to x square, which is generally called as a parabola, and the mouth showing upwards. Okay, parabola, and the mouth showing is upwards. Okay, now if we consider a equals to minus 1, so that means what it is? A less than 0. Okay, if a less than 0, then the curve will become y is equals to minus x square. Okay, y is equals to minus x square. So again if we plot for x and y, okay, again if we plot for x and y, so which is the same, but if it is 0, okay, the x is 0, y is 0, x is 1, y is minus 1, okay, 1 square, and y is equal to minus of 1 square, and x is equals to minus 1, we will get it as a minus 1, and x is equals to minus 2, we will get it as minus 4. Sorry, x is equals to plus 2 or for minus 2, we will get it as a minus 4, or for minus 3 and plus 3, we will get the result as 9. Now we try to plot the curve for this y is equals to minus x square. If we draw the plot, what is, if x is equals to 0, we will get it as y is equals to 0, and whereas which is the positive real axis and positive vertical axis, but the negative vertical axis is showing the downwards negative vertical axis, and which is the negative real axis. Okay, right. So now what it is, if x is equals to 0, we are obtaining it is as a 0, and if x is equals to minus 1, okay, if x is equals to plus 1, or for x is equals to minus 1, we are obtaining the value as simply as minus 1. Okay, we are obtaining the result as minus 1. For x is equals to minus 2 and plus 2, okay, for x is equals to minus 2 and for plus 2, we are getting the resultant as okay, plus 2 or minus 2, we are getting the resultant as minus 4. Okay, similarly for plus 3 or minus 3, we are getting the result as minus 9. Okay, if we join all the points, okay, if we join all these points, okay, if we join all these points, then we are obtaining in this manner, okay, which is generally a curve of a parabola, okay, which is generally a curve of a parabola. So mouse showing downwards, okay, mouse showing downwards. Now we are able to identify that. So y is equals to x square and y is equals to minus x square. Okay, so in this one we can write it as, if y equals to ax square is a curve, for this one, if a is greater than 0, the first condition, if a is greater than 0, then what we are getting, so y is a upward showing parabola. Okay, so if a is less than 0, if a is negative, then we are getting the curve as a downward mouth opening parabola. Okay, and here we are having y equals to some a times of x square, means which is also be written as y minus 0 equals to a times of x minus 0 whole square. Okay, that means here, so that's why we are getting the vertex of this parabola, the vertex of this parabola at origin 0 0. Okay, the vertex of this parabola we are obtaining it is at origin. So if anything changes in the x and y direction, okay, if we are shifting the vertex to a particular parameter, now how to represent, okay, so the 0 0 vertex, okay, before it is having at for example at 0 0, so which is y equals to ax square, which is also nothing but y minus 0 equals to a times of x minus 0 whole square. If it is shifted to some, okay, in x direction it is moved to h units, and in y direction it is moved to k units. Now it is shifted to over here h comma k. Okay, it is moved to over here h comma k. Now what, how this can be represented, how this curve can be represented? So this curve is represented, y minus, y is shifted in the positive direction, so y minus k equals to a times of x minus h whole square. Okay, so which is the given curve, y minus k equals to a times of h minus x whole square. Okay, so this is the way of representing the, what is a parabola if it is shifted to h comma k units. If the plot is in the form of y is equals to ax square is shifted to h comma k, the vertex is shifted to h comma k, so then we can write the transformed equation as y minus k equals to a times of h minus x whole square. Okay, this is related to graph of a curve which is in the form of a y is equals to ax square. Now we will come back to our concept, how to find out the maximum and minimum value of given quadratic equation. Okay, so now consider the quadratic equation, which is the general form of a quadratic equation is y equals to ax square plus bx plus c. Okay, which is the general form of a quadratic equation. That quadratic equation I am considering with y, so which is equals to, equation means equals to 0. In general, y is also be considered as f of x. Okay, y is also be considered as f of x. Okay, so now the f of x equals to, we are assuming ax square plus bx plus c equals to 0 quadratic equation. We are assuming it is as a some function f of x, and we are representing that with y equals to ax square plus bx plus c. And we have just previously seen that what it is, y equals to, if we write this is as, okay, a times of, okay, if we take a as a common from this one, x square plus b by a times of x, so which also be can be represented, please watch the previous video, sign of the quadratic expressions. In that one we had seen this, if this can be 2ab, okay, so a square plus 2ab Okay, we can write the b by 2a, and b square must be b square by 4a square added and subtracted b square by 4a square, and we have plus c by a over here if we take a as a common. And if we simplify this, we will get this is as a times of, okay, a times of x plus b by a, b by 2a, okay, x plus b by 2a whole square plus, okay, then what we'll get over here, 4ac minus b square by 4a square. Okay, if we further simplify this, we obtain it is as y equals to a times of x plus b by 2a whole square, and if we multiply over here, what we'll get, 4ac minus b square by, if a is multiplied, we'll get it as a 4a. Now if we further write this is as y minus of 4ac minus b square by 4a, okay, y minus of 4ac minus b square by 4a, which is equals to a times of x minus of, I can write this as minus b by 2a whole square, okay, x minus of minus b by 2a whole square. Now which is representing the above equation, which is representing the similar to the above equation, which is in the form of y minus k equals to a times of x minus h whole square. Okay, so that means the same quadratic equation, the resultant of the quadratic equation ax square plus bx plus c equals to 0 is nothing but a parabola. Okay, y is equals to ax square plus bx plus c. We had written this is as y minus 4ac minus b square by 4a equals to a times of x minus of minus b by 2a whole square. Okay, x minus of minus b by 2a whole square. Now if we plot this one, so which is in the form of x minus k, y minus k equals to a times of, so y minus h, okay, y minus k equals to a times of x minus h whole square. So that means, so h comma k is the vertex of the parabola. So now the given ax square plus bx plus c is shifted to, okay, a new vertex. That vertex is, what is that vertex? What is h is nothing but minus b by 2a comma, and which is in the form of 4ac minus b square by 4a, and this will be obtained when this will be upward showing parabola. In this one, if a is greater than 0, we will obtain this condition. Okay, the same quadratic expression in this manner. If a is less than 0, so what is the condition if a is less than 0? Just we have seen that if a is less than 0 and which is shifted to h comma k, okay, some h comma k, so h comma k, either it is positive or negative depending on our condition, so it is shifted over here, then we will obtain as some, okay, then we will obtain as, so which is the minus b by 2a comma 4ac minus b square by 4a, so which is, okay, minus b by 2a and 4ac minus b square, okay, here it is square by 4a, which is the a less than 0. So finally we can conclude that, so we have y equals to ax square plus bx plus c. Okay, we have y equals to ax square plus bx plus c is a curve depends on, so the first condition is if a greater than 0. The first condition is if a greater than 0. So we had that if a greater than 0, that is the upward showing parabola. Okay, it is the upward showing mouth opening, upward mouth opening parabola. And now we we'll analyze this. Okay, depending on the values of x. Okay, depending on the values of, now the x has three conditions depending on the discriminant. So if the discriminant is greater than 0, the roots are real and distinct. Okay, roots are real and distinct. Okay, if the discriminant equals to 0, the roots are real. Okay, real and equal roots. Okay, the roots are real and equal. And if the discriminant is less than 0, the roots are complex. Okay, now, so the discriminant is less than 0, roots are complex means that does not lie on the imaginary axis. So then we can write this as a greater than 0 means the parabola has to be, the curve ax square plus bx plus c has to be represented as some upward showing parabola. Okay, upward mouth opening parabola, where, so this can be written as, okay, why? Because if the discriminant is less than 0, the roots are imaginary. Imaginary means that does not lie on the real axis, it does not touch the real axis. Okay, it does not touch the real axis. Now here we have the condition. What is this vertex? This is now the vertex, and wherever in the quadrant it is, either is in the third quadrant or whatever it is above the real axis. Okay, it is above the real axis, second or first quadrant. And here is h comma k. What is h? Minus b by 2a, and y is 4ac minus b square by 4a. Okay, 4ac minus b square by 4a, and this is the condition if a is greater than 0 and the discriminant is less than 0. Okay, discriminant is less than 0. Complex roots. Complex roots means that does not on the, that does not touch the real axis, it is above the real axis. Okay, now if the roots are equal, if the roots are equal means this parabola touches the, okay, this parabola touches the equation ax square plus bx plus c touches the real axis, x axis, then we can write this parabola in this, draw this parabola in this manner. Then which is the condition for a greater than 0 and discriminant equals to 0. And what is the point over here? Minus b by 2a, h comma k only, but it touches the vertex, the parabola has to touch the, what is real axis? Minus b by a comma 4ac minus b square by 4a. Okay, which is the discriminant equals to 0, the roots are real, okay, and equal. If the roots are real and distinct, if the roots are real and distinct, the equation has the two solutions. Let this one is alpha and this one is beta. So that means the graph has to cut these 2 points. Okay, the graph has to cut these 2 points, then we can draw in this manner. So now what is this condition? Upward showing mouth opening means a must be greater than 0 and it is having the distinct roots. These two values will satisfy, these two values will make the given quadratic equation equals to 0. Then we can write this as discriminant is greater than 0. Okay, if the discriminant is greater than 0. Now the vertex is over here. Again the vertex is minus b by 2a comma 4ac minus b square by 4a. Okay, which is the vertex. Okay, from all these graphs we can conclude that now, whereas this vertical axis is our function f of x are the y values, vertical axis is the y values. Okay, vertical axis is the y. So now all these concepts we can say that, so if a is greater than 0, the curve ax square plus bx plus c, the quadratic expression ax square plus bx plus c will have, whereas this minus b by a at x is equals to minus b by a, at x is equals to minus b by a 2a, at x is equals to minus b by 2a, and whatever the condition it is, discriminant is greater than 0, less than 0 or equals to 0, at x is equals to minus b by a 2a, we obtain the y equals to 4ac minus b square by 4a. Okay, 4ac minus b square by 4a. Now we can conclude that, so if a is greater than 0, the function or the curve ax square plus bx plus c will have the minimum. Okay, why? Because it is the minimum value at any condition. It is the minimum value of the y. Okay, the minimum value y minimum over here, and y minimum, this is the y minimum. Okay, so next this is the also y minimum. Okay, it is also y minimum. So that x is equals to minus b by 2a, and we will obtain the y value. So why? Because we have the condition as what we have, y minus 4ac minus b square by 4a equals to a times of x plus b by 2a whole square, where x is equals to minus b by 2, this is equals to 0, and we will obtain the y equals to 4ac minus b square by 4a. So always at x a greater than 0, at x is equals to minus b by 2a, the y will have, f of x will have the minimum at, okay, f of x will have the minimum at, or y will have the minimum at x is equals to minus b by 2a, and the minimum value is what is 4ac minus b square by 4a. Okay, now we move forward the another condition. If a is less than 0, okay, if a is less than 0, that is the negative value of a. Okay, if a is less than 0, what will get the next condition? If a is less than 0, the curve will get it as a downward mouth opening parabola. Now for a less than 0, again what the condition will obtain, it is as y minus 4ac minus b square by 4a equals to a times of x plus b by 2a whole square. Now a is less than 0. Okay, that means a is a negative. Then we'll get it as what it is, if the discriminant is less than 0. Okay, if the discriminant is less than 0, it is a downward showing parabola and does not touch the real axis. Okay, if it touches the real axis, then it has the distinct roots. So that's why we need to show over here, this is a sum, it does not touch the real axis. This is the way. Okay, the parabola does not touch the real axis, which is the real axis. It does not touch the real axis. Then now the vertex is, what is the vertex? Minus b by 2a comma 4ac minus b square by 4a. Okay, now this is the condition, and over here what we are getting, this is the y value. Okay, and it is starting with what is minus infinity to y. So now we'll get over here minus 4ac b by minus b by 2a, this is the x, and 4ac minus b square by 4a is, and the condition is a less than 0 and discriminant is also less than 0. Now the roots are equal. If the roots are equal, what happens over here? If the roots are equal, the curve has to touch the real axis. The curve has to touch the real axis. The two roots will present over here. Now it is minus b by 2a. The vertex is 4ac minus b square by 4a. Okay, so now we have over here, and this is from minus infinity to, which is the y value. Okay, so next, and it touches the real roots, discriminant greater than 0, it has to touch at two instants. The curve has to touch the two instants of what it is, real axis, two instants of the real axis. Then we can draw in this manner. Okay, now we can draw in this manner, which is nothing but, and over here, coming over here, what is a less than 0, discriminant equals to 0, and a less than 0, discriminant is greater than 0. It has the two real roots, discriminant is greater than 0, real and distinct roots, and we will obtain the condition, and where this is the value of what it is, at x minus b by 2a comma 4ac minus b square by 4a. Okay, 4ac minus b square by 4a. Now this is the y value, and this is what is the minus infinity. It starts with from minus infinity to reaches. Okay, so the minimum value, it is reaching the minimum value 2, then we obtain this is as a maximum value, and it is reaching from the minimum value to it is obtaining it is as a maximum value. Okay, from the minimum value to obtaining a maximum value. Okay, now we can say that, so if a less than 0, okay, if a less than 0, okay, the curve will have, okay, the curve will have maximum, okay, the curve will have the maximum at x is equals to minus b by 2a, and that maximum value is, okay, and that maximum value is, that is y maximum equals to 4ac minus b square by 2a. Okay, now this is the way of finding the minimum and maximum values of the given quadratic equation, and I am summarizing over here. So if y equals to, or f of x equals to ax square plus bx plus c will have, okay, depending on if a is, okay, greater than 0, okay, if a is greater than 0 will have minimum, okay, will have minimum at x is equals to minus b by 2a, and minimum value is, and minimum value is the y value. What is the y value? 4ac minus b square by 4a. And the another condition is, if a is less than 0, we will get the curve as a downward mouth opening curve, and at this case we will get the maximum at x is equals to minus b by 2a, and the maximum value is, so what is the maximum value? 4ac minus b square by 4a. So now this is all about the concept of maximum and minimum values of a quadratic equations. In the next lecture we will solve few problems based on this concept. Thank you.